number 7. So for vectors A, B, and C in the figure below, they tell us a couple angles in there. The other one nicely goes in a cardinal direction. Find the following scalar products, which A dot B, B dot C, C dot E. So, all right. So remember, with a dot product, we're doing the parallel sections of them. So for the first one, I'm going to take and I'm going to redraw it just to bring it into mind. So I'm doing A dot B, I believe, wasn't it? All right. A dot B, yep. So I'm going to draw vector A, which would go right here, and then vector B, which would go right here. And this is the angle phi between them. And so I'm the dot product of these two. It's the absolute value of A, absolute value of B. Longer. And then I want the part of B that's parallel to A. And so is that the sine or the cosine? Just remember. Oh, sorry. I forgot to label it. Cosine, right? Yeah. It's a little hard to see here because I could think of it as the components of B, and then I would just, it would be cosine of the theta 2. Let's look at this another way, just to bring you up to another way to look at it. If I've got these two here, and I break B into components here and here, this is B, and this is theta 2 in my case. I'm interested in multiplying A by B cosine theta 2, right? And they're in opposite directions. So, but if I'm looking at just the two, phi is the angle between them, and it's cosine still. So, I have my value of A, which is 8.00 meters. My absolute value of B, which is 15.0 meters. Cosine, and my phi is going to be, let's see, it's going to be 90. Actually, it's going to be, I'm going to look at it this way, as if it was all the way around, it would be 180, but then I come back theta 2, so I'm going to do it as 180 minus theta 2, which is 180 minus, in my case, 34 degrees. So I get 146 degrees. Let's see if that comes out correct. I should probably check my mode, and I'm in radians, so I don't want to be in radians. I need to be in degrees. There we go. So, good thing to always check, right? So I'm going to do 8 times 15 cosine 146. And I get negative 99, which is good. I expected a negative value because they're pointing in opposite directions. So negative 99.5. See if on a Friday afternoon the first one goes in right. All right, so we're going to do one of the ones here on number 9, where we've got vectors A and D in the figure below have the following magnitudes. And find the magnitude and direction of A cross D, or find the magnitude of D cross A. And then the direction. So I'm going to kind of think of the direction first of A cross D. Remember, I point my fingers in the direction of the vector, and then, so I've got my right hand pointed in the direction of A, and then I want my fingers to curl in the direction of D, and that I can only do that if my thumb points into the board, right? Or I can do my 3-fingered salute, and my forefinger goes down, my middle finger goes off to the left, and my thumb therefore goes into the board. Either way you think about it, your thumb is into the board. So that should be the Z negative direction. Let's see if that is right. Z negative. Yay! And now I just need to do the magnitude of that. So the magnitude of A cross D is absolute value of A, absolute value of D, sine of the angle between them. The angle between these two is this one in here, where, so if I put in all my values to the absolute value of A, 7.95 meters, times absolute value of D, 9.2, and they left that unitless so that the units would come out to be meters. Now, remember, when I'm really interested, another way to think about this is the component of D that is perpendicular to A. That's what the sign is trying to get me. But in this, so in this case, the angle, direct angle between them is going to be 90 plus, let's see, 90 minus 53 is 37. 90 degrees plus 37 degrees is my angle between them, right? It's 90 to get me up to the X negative axis, and then 37 to get me up to D. Let's see, so 7.95 times 9.2 sine 90 plus 37. I get 58.4 as the magnitude of this cross product that's pointing into the board, into the X, the Z negative axis. Let's see, 58. So if I was actually to draw that on my diagram here, okay, what I would need to draw would be a vector into the board. So I'd need to draw this and then label it that 58.4 that I found. The magnitude is always just numbers, a value. It doesn't have positive or negative. How do I know that it's into the board? Well, because I did my right hand rule. Negative Z. Oh, sorry. By convention, and that's the part I didn't copy. By convention, X positive points to the right, Y positive points up, and Z positive points out of the board. Because again, it's the magnitude of my angle. Yeah. I've already taken care of all that directionality, and I'm always going to pick the angle less than 180. All right, to stay within that first part, that first half of the sine curve. All right. And so then if I have DA, remember I point my fingers in the direction of D, curl that, or point my index, curl my fingers, or point my other one in the direction of A, so I'm D, and then I think of it as curling to A, and to do that, my thumb points out of the board. So while A cross D points in, it makes sense that D cross A points out. Is it going to be the same magnitude? Give it a try. Tell me if it's the same magnitude. They're the same absolute value, aren't they? Sine function has the same angle.
Yay.
Yay! See, so some of those symmetry relationships, it's good to practice and just realize that. You know, save yourself a little time. All right, so we're going to do math review number 15 here. A table of values for f, g, f prime, and g prime are given, where f prime and g prime, of course, is the derivatives, the first derivatives of f and g. If h, the function of h, equals the function f of the function dx, find h prime of 1. The derivative at 1. All right. Fun calculus. All right. So, let's see. We have to remember some of our calculus rules here. Now, you guys will have references to do these with. So let's make sure you know where they are also in your book. All right. If you grab your book, if you don't have yours here, there are a couple extra copies in the back. Yeah. Feel free to use those while you're here and just return them. And I'm going to pause here just to record. So what we want to do here is we want to take the derivative of h at the value x of 1. Okay? So what that's going to give us, let's see, h prime of x would equal f prime of g of x, because we take the integral, the derivative of the outer function, and then we need to also incorporate here the derivative of the inner function. So this is times g prime of x. Right? That's why, like, let's say that we had just, I don't know, call it b of x equal x squared. If I did b prime of x, that would be 2x dx. Yes? Because I'm taking of the function squared, but I'm also, I need that dx in there. So this should be, let's see, we should have f prime, we're having 1 here. Right, so we have f prime of g of 1 times g prime of 1, which should be, stop flashing it, f prime of g of 1, let's see, g of 1 is 2, so f prime of 2 times g prime, I'm sorry, I put an extra parentheses in there, times g prime of 1, that up, which is f prime of 2 is 5, g prime of 1 is 6, I believe mine is 30. Let's see if I'm right on Friday. Did I get that right this week? 2 is 5. 6, okay. Should be 30. Yay! And similarly, I can do the same functionality for the second one. Yes, no. Now, we didn't need to use the table I pointed out to you guys, but I wanted to point out so you knew it was there. So that if you're, memorizing the chain rule or anything like that, you can just do them out. So here, I'm going to end up with G prime of f of x all multiplied by f prime of x. And then substitute in the correct values for 1 into there. And I'll end up with the same thing. Same idea.